In this video, we will learn how to solve binomial problems of a more advanced nature. Before we look at examples, I would like to explain the difference between two functions of TI-84 that have something to do with binomial distribution. These two functions can be accessed by clicking second and bars, which are going to take you to the distribution menu. And if you scroll up or down, you will get to two options. Option A, Binomial PDF, option B, Binomial CDF. So what is the difference between them? Let's say we have number of trials 7 and probability of success of 0.85. If I want to know the probability that x is exactly 5, means I have exactly 5 successes in 7 trials, I will use Binomial PDF to compute that probability. It will only find the probability of this one value of 5 successes. If I want to find probability of x being less than or equal to 5, it means I'm looking at a combined probability of having 0 successes, 1, 2, 3, 4, up to 5 successes. And binomial CDF is the function that will do that for me, using same parameters, 7 trials, 0.85 as probability of success, and x equals 5. But the difference between them is that binomial CDF adds up all of these probabilities and gives me the total. Please note that your calculator does not know how to compute probabilities when x is greater than some number. In those cases, we will have to use complement rule and use the binomial CDF to work with those kind of questions. I will demonstrate that shortly. Here is our first example. The manufacturer of a fertilizer guarantees that, with the aid of the fertilizer, 80% of planted seeds will germinate. Suppose the manufacturer is correct. If 8 seeds planted with the fertilizer are randomly selected, what is the probability that at least 7 of them will germinate? Carry your intermediate computations to at least 4 decimal places and round your answer to at least 2 decimal places. Let's summarize what I know from the given story. I know probability of success of 0.80. I know there are 8 seeds, which means 8 trials, and we're wondering what is the probability that at least 7 of them germinate. So my special boundary point is 7. So maybe 0 seeds will germinate, or 1 or 2 or 3 or 4 up to 8. So these are all of my possible outcomes. The question here specifically is asking what is the probability that at least 7 germinate, which means 7 or more. In this case, 7 or 8. If I write this in a more concise form using mathematical symbols, it is same as probability that x is greater than or equal to 7. But a calculator doesn't have a function that deals with this inequality symbol. Remember, TI-84 only can do probability up to a certain number, which means less than or equal to some number. So I need to use the complement approach to solve this problem. What is the complement event of getting at least 7 seeds to germinate? Really, if this is my boundary line that separates my event from its complement, it means getting up to 6 to germinate. So I'm going to use the complement approach. 1 minus probability that x is less than or equal to 6. 1 minus binomial CDF, 8 trials, probability of success 0.80. 6 is my value of x this time, and it comes out to be that rounded to 2 decimal places, the result is 0.50. Let's take a look at example 2. A new surgery is successful 70% of the time. If the results of 6 such surgeries are randomly sampled, what is the probability that at most 7 of them are successful? We need to round to 2 decimal places again in this question. So what I have is this. Probability of success is 0.70. We are considering 6 surgeries, so my number of trials is 6. And I'm aiming at 3, in this case up to 3 successes. Probability at most 3 are successful is same as probability of x being less than or equal to 3. I'm using binomial CDF with 6, 0.70, and 3 as my parameters, which gives me 0.26 rounded to 2 decimal places.